We are starting section 11.1, the fundamental counting principle. And this is actually a pretty, I consider, fun chapter because we get to use a lot of things that are daily use items. But the fundamental counting principle comes with this. If you can choose one item from a group of M items and a second item from a group of N items, then the total number of the two items chosen is M times N. I'm going to blow this up a little bit so we can actually read it easier. Let me go to 14. There we go. This semester that you will take, this is the semester that you will take your required psychology and social science courses. Because you decide to register early, there are 15 sections of psychology from which you can choose from. Furthermore, there are 9 sections of social science that are available at times that do not conflict with those for psychology. In how many ways can you recreate 2 course schedules that satisfy the psychology social science requirement? Okay, and this is a very easy problem. If there are 15 sections of psychology to choose from, and there are 9 sections of social science courses to choose from, then my answer is just simply the number from A times the number from B. And 9 times 15 is a calculator. 9 times 15 is 135. There are 135 different ways to choose those 2 courses for this section. Straightforward and easy. Okay. Now, the second part of this, the fundamental counting principle extends on to more than 2. Okay? The number of ways in which a series of successive things can occur is found by multiplying the number of ways each thing can occur. So now we're going to throw in this other idea here, which again, I'm going to blow up to 14 just so we can read it. Next semester, you are planning to take 3 courses, math, English, and humanities. Based on time blocks and highly recommended professors, there are 8 sections of math, 5 of English, and 4 of humanities that you find suitable. Assuming that no scheduling conflicts, how many different 3-course schedules are possible? And again, just following the same rule, there are 8 sections of math, there are 5 of English, and 4 of humanity. 8 times 5 is 40, times 4 is 160 different ways to do this problem. Then the next example. You are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices, with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, how many different ways can you answer the question? I got to pause for a minute. I apologize for that. I had to take a phone call real quick. So back to reality. We are talking about the 4 questions, the multiple choice questions. And in this one, I'm going to set this up a little differently. I'm going to do some lines here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many different ways are there to answer the first question? Well, you can answer A, B, C, or D. So there's 4. How many ways to answer the second one? 4. How many ways to answer the third? 4. And I can go on, blah, 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 out here. And it is actually 4 times 4, or 4 to the 10th power. I'm going to show you how to press that into your calculator real quick here. So I grab my calculator and I take 4, and then to do the power, it's this button right here that looks like a upside down V. You click that button, it'll give you the power button, and you press the 10 here and enter. And there are 1,048,576 ways to answer a multiple choice question, or 10 question multiple choice test. That's a lot of ways. Okay, but that's the fundamental Calorie theorem in that respect. And our last example has to do with telephone numbers. Telephone numbers in the United States begin with 3 digits. Area codes followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with a 0 or 1. How many different telephone numbers are possible? I'm going to attack this the same way. I've got my area code, which is in Wyoming 307. The local telephone numbers 855-2180 is my office phone number. So those are the possible, or those are the possible numbers. How many different ways are there to choose the first number in the area code? We cannot use 0 or 1. So this number right here cannot be 0 or 1. So there are only 8 ways to choose that one. How many ways are there to choose the next one? 10. How many ways are there to choose the next one? 10. And then the first digit of the prefix or very local telephone number cannot begin with 0 or 1. So there's only 8 ways to choose this one. After that, there are 10 ways to choose this, 10 ways to choose this, 10 ways to choose this, 10, 10, and 10. And the fundamental counting principle says that I'm going to do 8 times 8, or 8 to the second, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 power. 8 to the second times 10 to the 8th. If I grab my calculator, 8 to the second times 10 to the 8th, and I get overflow. Whoa. I think that would be an overflow. Just a second, let me make sure I press the right values. Oh, I see what I did. I forgot to press the right arrow button. 8 to the second, I have to press the right arrow to get out of the thing, times 10 to the 8th, enter, and I get that huge old number, 6, 4, and 1, 2, 3, 4, 5, 6, 7, 8 zeros. So millions, trillions, so 6,400,000,000,000. That's it for the fundamental counting theorem or principle for today, section 11.1.